imagine a butterfly flaps its wings in Brazil. A month later, a tornado hits Texas. This isn't a metaphor. This is chaos theory, the science of why we can't predict the weather, or stock markets, or the orbits of planets. Let me show you why. Welcome to chaos theory, one of the most mind-bending discoveries in modern science. Today we'll explore 4 examples that prove our universe is fundamentally unpredictable, even when the rules are simple. In 1961, Edward Lorenz was running a weather simulation. He paused, then restarted by entering the same numbers, but he rounded them slightly. 3 numbers off by less than 1/10,000th. The forecasts diverged completely. He called it the butterfly effect. Here are 100 double pendulums. They start at angles that differ by less than 1/10 of a degree. For a few seconds, they move together. Then they explode into chaos. Same physics, same starting position, completely different futures. 2 bodies orbit each other in perfect ellipses. Newton solved that 300 years ago. Add a 3rd body, and the math breaks. There is no formula that predicts where they'll be. We have to simulate it. And tiny differences in starting position lead to wildly different paths. This is the Lorenz Attractor, the shape of weather. 3 simple equations describe it. The system never repeats, never settles, never escapes. It traces this beautiful butterfly forever. This is what chaos looks like in 3 dimensions. Chaos is everywhere. In dripping faucets, in heart rhythms, in turbulent fluids, in the firing of your neurons. The systems look random, but they're not. They follow strict rules, they're just so sensitive to initial conditions that prediction becomes impossible. Chaos theory teaches us humility. The universe is deterministic, every effect has a cause. But it's also unpredictable, the smallest cause can grow into the biggest effect. If this video helped you see why, subscribe for more science made visual. Next time, the mathematics of fractals.